So this video is going to be about finding slope of a line, but using the slope formula. So here we have a line, and we have this just here for a reference. So we're just going to use these points, but we'll check our answer on the graph when we're finished. So here are 2 points, the point 3, 7, 3 to the right, 7 up. That's that point right there. I'll label it on here, point 3, 7. And this is the point 7, 4. Now again, we don't need this graph to find the slope because we have the coordinates, but we'll use it as a reference. So the slope, the formula for slope, or the definition, is the change in the y values divided by the change in the x values. So the slope formula is y2 minus y1 divided by x2 minus x1. Now we might wonder, what are these y2, y1s? It's actually kind of simple. This is my first, as I go left to right, this is my first coordinate that I've marked on the line, and this is my second. So this is the x coordinate and the y coordinate for this first point. So I'm going to call them x1 and y1 because they're the x coordinate of the first point and the y coordinate of my first point. And then by that same logic, I'll call this x and y. Right, those are the x and y coordinates, but this is my second point on my line that I'm going to use for slope. So this will be x2, and this will be y2. Oops, just put 2 there. So now I have x1, y1, the first point, and x2, y2, the second point that I'm going to use. So now I just plug those values into the slope formula. So it's good to write the formula first when you're doing your work. Don't just go straight to the numbers. Write the definition of the formula you're using so you can substitute correctly. And so I need to substitute my y2 value here. Actually, another thing that's good to do is when you do the substitution, put your subtractions in first, then you don't mix them up if they're negatives. So I like to set it up this way and then kind of put the numbers in after. So y2 goes right here, and notice my y2 is 4, so I put a 4, minus my y1 value is 7, my x2 is 7, so that goes here, x2, minus, and my x1 is 3. And so then I just do that calculation, and I'll find my slope. So 4 minus 7, so those have different signs, so I subtract. And I use the sign of the number with the greatest absolute value, which is negative there, so this will be negative 3. And here I have 7 minus 3, different sign, subtract again, so that's 4. So I have negative 3/4, and that's the slope of my line. And remember, when we're thinking about slope, we want to make sure we're not just thinking of this as the fraction 3/4, but as, what it means in terms of the movement of the line. So a slope of negative 3/4 means that this line from left to right goes down 3 for every 4 it goes to the right. So let's check that on our line. So if we start on any point, if we go down 3 and right 4, we can see we keep landing on the line as we go down 3, right 4. And if we wanted to check, we could just do a slope triangle here between these points, right, and find our change in y. And we see we go down 3, so our change in y would be negative 3. And this would be our change in x. And we can see our change in x, 1, 2, 3, 4. So we would have gotten negative 3/4. Same that we find here. So again, using the slope formula is great when you don't have the graph. You only have coordinates, or just when you would rather use the coordinates. Just calculate the slope. But again, always think about what you're finding, right? The slope of a line, how it's moving. Do another example. So we'll move this down. So here we see this line moves up from left to right, so we should anticipate that it would be positive slope this time. Now I picked this example. You're going to see here that we're going to have to be very careful with our subtraction, so I chose these points to demonstrate that. So let's proceed. So This is my first point. This is the x-coordinate of my first point of the 2 points. This is my y-coordinate of my first point, so I call it y1. So it's always good to label these. This is the x-coordinate of my second point, and the y-coordinate of my second point, meaning just this is the first point I listed, the second point I listed on my line. And then I just make substitutions. So here it says the definition of slope, or the slope formula, is y2 minus y1 divided by x2 minus x1. So, and I just substitute those numbers in. Now again, watch very carefully. I'm going to put the subtractions from the formula in right away. This is very important because notice we have these negative numbers here. So make sure you substitute the numbers in the correct spot. So y2 is my first number, so that's 7. The subtraction's already there. Now I'm going to subtract my y1. Now notice, y1 is negative 8, so that's, we don't want to just put one subtraction or one negative sign. This subtraction comes from the equation. This negative is coming from the coordinate. And then here, x2 is 3. This subtraction is already there, minus x1. So I plug in negative 6. And if you want to put those in parentheses, you can. I'll go ahead and do that. You don't have to, but it's nice to do that. So now we know that when we subtract a negative, that is the same as adding a positive. So this will actually become 7 plus 8 and 3 plus 6. So I chose these because I wanted to demonstrate that sometimes you're going to end up with a situation where it's minus a negative. And 7 plus 8 is 15, and 3 plus 6 is 9. So we have a slope of 15/9. That means this line goes up 15 when it goes to the right 9. And if we want to check on our graph here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that corresponds to our change in y15. And then we should go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can see we land on our line. So it's the correct slope, just as if we found it using a slope triangle. But in this case, we don't need the graph itself. We just need the coordinates. And that's slope formula.